Hello everyone, welcome to another video from Mastery Tutoring. So this is a live session. In this live session we're going to be talking about Euclidean geometry. So consider this to be part 2 of the first part. So now we're going to continue with the questions that we were doing from Euclidean geometry. Now the question that we have on the board, it says O is the center of the circle, and then we are required to find the value of J and the value of K. So we're gonna go ahead and do it and solve this question. So it depends on you actually as to how you want to solve this question, as to like what do you want to start with. Do you want to start with K or do you want to start with J? So personally I choose to start with K. So once again, all the information that I'm going to put in this drawing, they're going to be in red. So all the information that is white was given to us, and then all the information that is going to be in red is going to be the information that I'm going to put in the diagram. Okay, so now we go. So now here you'd agree with me that OA is the diameter of the circle, is the radius of the circle rather, not a diameter but the radius of the circle, and then also OB is also radius of the circle. So now they are equal, so this is equals to that. Now because they equal, triangle OAB is it's an isosceles triangle, so this angle has to be equals to that angle there, so meaning that this is gonna be K. So let me write it here. So we say that angle OAB is equals to angle ABO, and then the reason for this is that we have an isosceles triangle OAB, because OA is equals to OB. Okay, so now this implies that OAB is going to be K, just like I've shown it in the diagram there. Okay, so now the next thing that we're going to do now is to add, since we're looking for the value of K, we're going to add all these angles, these three angles there. They're going to sum up to 180 degrees. So we start by saying AOB plus OAB plus ABO is equals to 180 degrees. Now the reason for this, because I don't have space, I'm going to write it down here. The reason for this is that angles in triangle sum up to 180 degrees. So this is going to be our reason there. So therefore, we know that OAB is given to us as 78 degrees plus, and then OAB is K plus ABO is also K, is equals to 180 degrees. So now we simplify this. K is going to be 180 minus 78 degrees divided by 2. Okay, let me calculate this on my calculator. We have 180 minus 78 over 2. It gives me 51 degrees. So we know that K is equals to 51 degrees. All right. So now that we have K, we have to find the value of J. So now look here. So angle AOB is subtended from arc AB, or from the chord AB, depending on how you want to look at it. Also, angle ACB is subtended from the same chord or the same arc. So therefore, there's a theorem here that we know that says the angle at the center, so AOB, which is the angle at the center, is twice the angle at the circumference, which is angle ACB. Now the reason that we're going to give here, we say angle at center is equals to 2 times angle at circumference. Right. So we know that the angle at the center. Okay, first of all, we're looking for this guy. We're looking for ACB. Therefore, I'm going to make ACB the subject of the formula. ACB is going to be equal to AOB over 2. We know that ACB is J, and then OAB is given to us as AOB rather is given to us as 78 degrees divided by 2. 78 divided by 2 gives us 39 degrees. So now there's our solution there. So we know the value of K, which is 51 degrees, and then we also know the value of J, which is 39 degrees. We've solved this question. Let us move to the next one. Okay. Now on this question here, we are given this diagram here. They didn't tell anything. They didn't say anything about the center of the circle, but then they did tell us that AB is parallel to DE. This is a very crucial information, and we're gonna have to use it. Now, because we are given parallel lines, we can say that now this angle BDE is equals to angle ABD because of alternate angles. So what am I saying here? So this angle is going to be equals to that angle there. That's basically what I'm saying. And the reason for that is because the alternate angles. Let me put it in writing. So ABD is equals to, so ABD is equals to BDE. The reason for this is that alternate angles. So I'm going to say alt angles. Why? Because we know that AB, which is given to us, AB is parallel to DE. This is a given information. That's what we know. Therefore, ABD is going to be 33 degrees. Now let me indicate it there. Remember what I said. The information that I'm going to put on the diagram are going to be in red. Okay. So now we have that, right? We have this information. There's another theorem that says that if two angles are subtended from the same chord or the same arc, those angles are equal. So now allow me to draw this line. Look at this arc AB, right? Arc AB, two angles are subtended from this arc. The first angle is angle ABD. So let me mark it here. So we have angle ABD is subtended from that arc, and then also we have another angle which is angle AED. These two angles are subtended from the same arc, which is arc AD. Did I say AB? No, it's supposed to be AD, as in like ABCD, AD. So because of that, now these two angles have to be equal. I hope it makes sense for you. So ABD angle ABD is equals to angle AED. The reason for this, we say arc. You can simply say arc AD, or you can even explain that angles subtended from the same arc are equal. But then, in short, arc AD, it's acceptable. Another way that you can give reason for this is that you can say, you can draw a line now, a chord. You can construct a chord from A to D, and then you give a reason as chord AD, if you like, depending on how you want to put it, but I'm not going to use that. I think arc AD is fine. Okay, so now moving on now. So we know that we're looking for angle AED. Therefore, AED is going to be equals to ABD. ABD is given to us as 33 degrees. Well, it's not given to us. We've calculated it, and we found it to be 33 degrees. So we've solved this part. AD is equals to 33 degrees. Okay, let us move on to the next question. I see there's one viewer there. There's someone who's watching. If you like, you can drop a comment. Just say hi to me. Hello, viewer. Say hi to me. All right. Moving to question 5. O is the center of the circle. So O is the center of the circle, right? So now we need to find the value of Y and the value of Z. I hope it's visible on your side. So now, well, there's many ways in which you can solve this question, but I choose to start by finding the value of Z. I think it's very much easy. So look here. OC is equals to OD. Now the reason for that is that these two lines are radii of the circle. So because they are radii of the circle, this simply means that, okay, first of all, this is equals to that. Therefore, this angle is equals to that, because it becomes an isosceles triangle. Okay. So now, we are going to say now, I'm going to put in writing that angle ODC is equals to angle OCD. And then the reason for this is that we have an isosceles triangle OCD, because we know that OC is equals to OD. That is our reason there. Okay. So now, therefore, we know that ODC is given to us as 30 degrees plus Z. There it is there. And then also, OCD is given to us as 50 degrees. Therefore, when you solve for Z, Z is going to be 50 minus 30. Z is going to be 20 degrees. And this makes perfect sense. If you add, since this angle is equal to that angle, if you add 20 there, if you put 20 there, adding these two will give you 50 degrees. Therefore, it makes sense. Now we need to find the value of Y. Okay. Finding the value of Y now. So Y is subtended from chord AB, from arc AB rather. So there's our arc there, arc AB. And then now, we can see that, okay, let me do it this way, just to make sure that you see it. So you see this angle is subtended from that arc. And then we have another angle again, which is, I'm going to write it in green. So angle ADB. Both of these angles are subtended from the same chord, from the same arc rather. Therefore, we're going to say now angle AOB is equals to 2 times angle ADB. So angle at center is twice angle at circumference. This is going to be our reason. All right. So now we know that AOB is given to us as Y. Therefore, Y is equals to 2 times, and then ADB is given to us as 30 degrees. So 2 times 30. Therefore, Y is going to be 60 degrees. All right. So we are done with this part. Moving on to the next question, we're moving to question number 6. Now in question number 6, they're looking for the value of A and B. Okay, so the first thing that I'm going to do here is that angle A, okay, first of all, let me divide these two angles into two. So this one I'm going to call it O1, and this one I'm going to call it O2. So the O, because it's divided into two angles, I'm going to divide it like that. So now O2 is equals to 2 times angle A, B, C. And then the reason for this is that angle at center is twice angle at circumference. That is going to be the reason there. Since we're looking for ABC, therefore ABC, we're making it the subject of the formula O2 over 2. And we know that ABC is given as A, so we're going to have 150 divided by 2, which is equals to 75 degrees. So we know now that our A is 75 degrees. Okay, and then now we need to find B. So for B, I'm going to solve it in two ways. I'm going to solve it in two ways, two methods actually. I'm going to solve it using two ways of. Okay. So let me say method method 1. So method 1, if you add O2 plus O1, it should give you 360. So the reason for this is that angles around the point. Okay, and then so since we're looking for O2, no, we're looking for O1. O1 is going to be 360 minus O2, which is going to be 360 minus 150, which is going to be 210. Okay, so now the next thing that we're going to do is that we are going to say O1 is 2 times angle A, D, C. And the reason for this is that angle at center is twice angle at circumference. Okay, so now since I'm looking for ADC is going to be O1 over 2. ADC is given to us as B, so B is going to be O1. I've calculated it to be 210. So there's O1 there, and the value is 210. Therefore, 210 degrees divided by 2, it becomes 105. That is the value of B. Okay, so this was method number 1. Let us look method number 2. Method number 2, when you add angle A, okay, first of all, let me write here that this is method 2. Method 2. So when we write here that A, B, C plus A, D, C is equals to 180 degrees, right? This is cyclic quad. So we have a cyclic quad here.